Welcome everyone to the last section of this course. In the previous section, we discussed pre-processing data to deal with dirty or inconsistent data. Now that we have some general ideas of how to manage and clean our data, now we'll go over how to plot and visualize it. Section 3 discussed descriptive statistics to summarize our data. Data visualization techniques are extremely useful to quickly and intuitively help us to understand trends, patterns, and the distribution in the data that will be harder to interpret through numerical results alone. For the remainder of this lesson, we'll go over one-dimensional and two-dimensional qualitative and quantitative plots. Specifically, we'll show you how to deal with visualizing categorical data by plotting pie charts that show, for example, the percent of departments that employees work under, or bar charts to show which suppliers offer the most number of products, to displaying numerical data such as line graphs, histograms, box plots, and stacked area charts. In order to help us generate charts, we'll be assisted by using the Matplotlib Python library. Matplotlib is another great free open source library, great for visualizations and plots. It has a lot of great features to quickly and easily generate charts that will also give us the flexibility to customize them for additional features. Matplotlib, like NumPy and Pandas, is a rich and extensive library where there are multiple methods and approaches to describing how to plot various types of data. Once again, we'll just cover some of the basic approaches, but you're highly recommended to check out the documentation for more information. To get started, Matplotlib has an object called the figure. The figure is basically an object that will hold our plots. So a rough analogy might be a window frame to hold our canvas before we draw our portrait. When we first declare a figure, it seems like an empty blank space. But if we want to actually draw charts, or several of them, we'll need to declare axes or subplots. We won't go through it in detail, however axes and subplots in Matplotlib are basically the same, except subplots follow a fixed coordinate in our figure, while axes give us the flexibility to choose our coordinates specifically. If the figure is our frame, then subplots and axes are the number of canvases we wish to hang on our frame. You can think of it as a collage of family photos and where we want to place them. For the remainder of this lesson, we'll just stick to subplots. Also note that when we're generating a chart, we'll need to decide which type of plots we wish to use, based on the type of data we wish to visualize. And also note that we can actually generate more than one plot for each subplot that we're using. An analogy, there might be multiple objects or faces in a single photo or portrait. The same is true in our subplots. From here we can decide if we want to add titles, axes, ticks, legends, and etc. To get started, let's first discuss one-dimensional qualitative data when we have categorical labels that we wish to analyze in a visual context. So like before, I went ahead and loaded the NumPy, Pandas, and Matplotlib libraries, along with our sales dataset. To get started, let's first discuss categorical data where we might be interested to know how frequent or persistent certain labels are. Say we have a toy dataset with labels A, B, C, and D, which show up with a frequency of 5, 10, 9, and say 3 respectively. In this case, we'll like to see how frequent the label A shows in proportion to other labels. A good visual for this case would be a pie chart. To generate our pie chart, so let's just go ahead and define our label data. To generate our pie chart, we'll first declare the figure and the axis object we'll use by calling the plt subplots method. Next, we'll call the axis pie method to generate a pie graph by providing the data and labels. Finally, we'll call the plt show method to properly display the image on our notebook. Now another option to generate the chart is to call it directly using the plt.py method. The main difference between both approaches is that one explicitly generates calls to the figure and axis, which can be useful if we want to customize the figure object further, while the second option is a more direct method. I'll from time to time jump between both approaches, but if you would like to learn more, I highly recommend checking out the documentation. Now let's check out to see visually which departments our employees work most under in the sales dataset. Almost 47% of our employees work under the clothes department. And then our second and third departments seem to be the pharmacy, health and beauty, and electronic departments. Now let's see what cities most of our customers live from our customers table. Once again, our pie chart gives us some pretty intuitive understanding of our distribution. So we can see that most of our customers live in San Francisco, and then Oakland is our second highest city. Alright, so another plot we could use is the bar graphs, which unlike pie charts, allow us to see trends in the data, especially when we're dealing with time series. For example, let's make up a hypothetical rain data set and plot the data in a bar chart. Alright, so just like pie charts, we need to declare the figure in the axis. However, to generate a bar chart, we instead use the AIX.bar method to provide the indices with the width. We could also change the color, provide labels, and see how much the standard deviation changes each month. Just like pie charts, we declared the figure in the axis. However, in order for us to generate the bar chart, we used the AIX.bar method and provided it with the relative indices and its width. We also set the labels, the title, and the ticks to make our visual more intuitive to read and understand. But we can also change the color, provide labels, and also set the standard deviation. I'll show you how. Now that we have a general idea of how bar charts work, let's visualize the number of products offered by each supplier. First, we'll need to merge the products and supplier tables to see where each product comes from. Next, we'll extract the supplier names and the frequency of each product per supplier. Now, it's important to note that we have roughly 9 supplier categories that might be difficult to read in a vertical chart. So I went ahead and produced a horizontal graph that makes the labels easier to read. To do so, I use the ax.barh method, which stands for the horizontal bar. Now, as we can see by looking at this horizontal chart, that the biomeds is the biggest supplier for our products. Alright, so this wraps up the first video for Lesson 5. In this video, we introduced the Matplotlib library, where we discussed generating pie charts and bar graphs for one-dimensional categorical data.